So it starts with this box, operations with functions, then you should see addition, subtraction, multiplication, and division written in the box to the right of it. And so we're going back to functions, and we've been kind of evaluating functions just on their own, but we can take two functions and add, subtract, multiply, and divide them. So like if I have one thing that's f of x, a function written out, and then one thing that's g of x, I can actually add those together, subtract them, multiply, and divide. I can even like stick them inside each other and have like function inception, which is kind of crazy.
Variables? What?
No, different functions. Oh. So to go through these, just like black and white, the rules, this is the notation that you would see. So if I have function f or f of x plus g of x, this is the notation that I'm going to ask you for. So the operation that you would do would be f of x plus g of x. And we're going to do a couple of examples down below. So if this is still confusing just looking at it like this, we'll go over a couple of examples before I send you out of class. So then, if this is addition, subtraction is f of x minus g of x.
Wait, is that what we're writing in equivalent?
Yes. So this is notation, and this is equivalent operation. So then for multiplication, it would be f of x times g of x.
Wait, what?
And then for division, it would be f of x divided by g of x. And so the domain of these is something that's really important to note, because for some of these functions, when we combine them, we're intersecting their domains. So what I mean by that is that we're taking the possible x values from f of x and the possible x values from g of x, and when we combine them together in this operation, we're intersecting their domains, and our new function or our answer will be that intersection. And so the domain can be restricted. What I mean by that is that there are limitations to the x values, specifically in this quotient operation or this division operation, because what can't I have in the denominator? Zero. So if I have something like 2x plus 1 in the denominator, I can't have x be something that is going to be equal to 0. So for this one, x could not equal negative 1/2. So this would be a domain restriction, and this is something we have to start thinking about for our possible x values for functions now that we know how to graph things, like put discontinuities at certain x values and represent the domains of piecewise functions. So now we have the knowledge of how to graph that. So for example 1, it gives us an f of x of x squared plus x and a g of x of 3x minus 1. It's this little box on the left under example 1. Can you guys see those two functions that are there?
Yeah.
So we have f of x equals x squared plus 1, or plus x, and g of x equals 3x minus 1. So in A, it wants me to add these together, or f, I can do this, f plus g of x. And so the way that I do this is I take f of x, x squared plus x, and I add it to 3x minus 1. And so when I do this, I end up with x squared plus 4x. Yep. X, oh, it's right there.
Or this example.
Yep, this is example 1a, so this is on the right. So when I do f plus g of x, or f of x plus g of x, I get f of x plus g of x. And my new function is x squared plus 4x minus 1. I combine like terms to get a simplified answer. And it also wants me to list my domain here. So my domain for this function, because there are no restrictions, I don't have a quotient, so my domain here is all real numbers.
Wait. What happens to the x on the end?
This x?
No, on the end of that.
So this notation is the same as f of x plus g of x. That's just what this notation means. I'm not multiplying. This is just the way that it's written in its function notation.
Okay.
So when I see something that looks like this, it means it wants me to do this.
Wait, how'd you know it was all?
Yeah, but then why don't? Then we didn't do that.
I took f of x
Oh, okay.
and I added it to g of x.
Wait, how do you know it's all real?
Because I can plug in any number for x here and get a y value. Like I don't have any x value restrictions. Like I can choose any x value I want and plug it in and get an answer.
Okay.
Alright, so this is A. For B, it's subtraction. So I'm going to use the same function here. I'm just going to square it. So for B, I have f minus g of x, which I can also write as f of x minus g of x. So then for this one, I would take x squared plus x minus 3x minus 1. So when I do this, remember I have to distribute this negative sign, so it becomes x squared plus x minus 3x plus 1. So then my new function would be x squared minus 2x plus 1. And my domain again would be all real numbers.
Wait, why is it plus 1?
Because when I distribute this negative sign, it's the same as multiplying this bracket by negative 1.
How do we know that the domain is all real numbers?
Because it's not in a quotient, or it doesn't have a denominator. So I'm going to be able to get a defined answer for any x that I choose to plug in.
Okay. Gotcha.
Okay.
There's a lot of these.
Yeah, there are. For C, I have f times g of x, which is the same as f of x times g of x. And this is where our work with polynomials and factoring really is going to start coming into play.
Do we just FOIL?
Yeah, exactly, because I have x squared plus x times 3x minus 1. So I do my first and my outer, so 3x to the third minus x squared plus 3x squared minus x. And so when I simplify this or combine like terms, I should get 3x to the third plus 3x squared minus x, or plus 2x squared minus x.
Yeah.
And my domain again, because I don't have a denominator, will be all real numbers. D is the first one where we're going to start seeing these domain restrictions because it's the quotient. We're going to be doing division. So I have f of x, so it's written as f of g of x, which is the same as f of x divided by g of x. So I have x squared plus x on the top and 3x minus 1 on the bottom. This is the most that I want you guys to be able to do with this. But here, so this would be what I'd accept as an answer. And my domain would be x does not equal positive 1/3. And the way I got that is that I set the denominator, so set denominator equal to 0. So 3x minus 1 equals 0. Add 1 to both sides. 3x equals 1. Divide by 3, divide by 3, x cannot equal 1/3.
Okay, what?
Yeah, that you.
Because if I have anything over 0, it's undefined.
Okay.
So when I have a denominator, I have to make sure that I'm not going to choose any x value that's going to make this function undefined. So if I plugged in 1/3 here, 3 times 1/3 is 1. 1 minus 1 is 0. that would make this function undefined, so there would be a gap or a break in the graph of this function.
Oh, okay, wait, can I write that down?
Yes.
Wait, I'm so. What's the answer?
This.
Okay.
So I just took f of x, which is x squared plus x.
So to find the domain limitations, you just set the denominator
Yep,
to
set the
zero.
denominator equal to 0. So step 1 would be that. Step 2 would be solve. So anytime I
How
have
do you set it to 0?
You just put it in for
3x minus 1 equals 0,
Oh,
and then I'd move the 1 over and I'd solve for x. So in order to get this equal to 0, x would be equal to 1/3, which I don't want because I don't want this to be undefined. Because if it's over 0, it's undefined.
Why can't x
So
equal
lost.
1/3?
Because then the denominator would equal 0.
So is that only like,
Oh.
3 times 1/3 is 1. 1 minus 1 is 0.
so is that only applied to the denominator?
It only applies to when I have fractional functions. Or if I have square root functions. Like I can't have a negative in the square root because that's imaginary.
this
So you'll
But that
see,
only applies to the denominator though.
well, if I have
is this gonna be going?
that's an imaginary number. So for this, remember when I did my parent function for this, I had it so that x has to be greater than or equal to 0. It's my domain.
I'm 15 minutes late for a doctor's appointment that I forgot about. Can I go do that?
Yeah.
Can I leave my stuff here? Or-
Sure. Yeah, I've got a class in here. So these are for things where I normally have domain restrictions. So if you look at your graphic organizer, remember that we went through all the different parent functions and we listed the domain, and most of the time the domain was all real numbers. But there were some, like the square root function, where x has to be greater than or equal to 0. Or the reciprocal function, the domain x cannot be equal to 0. So, for example, in example 2, my g of x is the square root of x. So if I wanted to do that, I'm going to just give you guys 1 minute left. So I'm just going to do the first 2 of example 2, and then the back will be your homework. So if I have f plus g of x, for f of x equaling x squared plus 9, g of x equals square root of x, this would be x squared plus the square root of x plus 9.
Why does that go in the middle? Oh, that's just what it
Just
is.
because of in standard format increasing exponents. And so for this, what would be my domain restriction?
X is greater equal to 0.
Yes, for x is greater than or equal to 0.
Wait,
Because
how-
even though I can plug in any number here for x because it's being squared, I can't plug in a number less than 0 here because
That'll be
a square
imaginary.
root of a negative number is an imaginary number or undefined.
Oh.
So even though I could plug in any negative number here, because I have a square root here, I can't have x be less than 0. So same thing with the negative. So it would be, for b, it would be f minus g of x.
So how do you do this?
This would be this. It would be x squared minus the square root of x plus 9 for this one, and also the same thing. Domain x is greater than or equal to 0.
Oh, okay. It doesn't get distributed in.
No, because if I do x squared plus 9 minus the square root of x, that's the same thing as just moving it. I can shift it in.
Okay.
It's really helpful to use fractional exponents for C and D. So we're doing a throwback to rational exponents, which I'm sure everyone is psyched about. So for homework for tomorrow, I want you to try and go through as much as you can. So mandatory homework is doing the additions and subtractions for all of these examples. And I want you to try and get through at least example 4, multiplication and division. Does that
In the
sound
sheet we were working
doable?
on today.
Wait, so it says tonight both of these are
I know, I'm gonna move it.
So this one is over here.
So I want you to do all the additions and subtractions and try and get through example 4, multiplication and division. I'll put it up on Canvas. Yep.
That's my.
Nope, not this one. This is a different sheet. Just this one.
Just this one here.
Do all of them and then do these ones also.
Or just do all of them.
Or you can just do all of it. That's good too.
Hey, Michelle.
Bye, see ya.